Hello and welcome. You are looking at a live view of Electron on the pad at Launch Complex 1 in New Zealand as we prepare to launch an orbital debris inspection mission for Astroscale. That is our 44th Electron you can see on the pad, ready for our second launch for the year at our scheduled liftoff time of 03:52 local time or 14:52 UTC. My name is Muriel Baker and I am joined by Neutron Systems Engineer Imogen Ray.
We're joining you from Rocket Lab Mission Control in Auckland, New Zealand, to take you through the final few minutes in the countdown for today's mission called On Closer Inspection. We've had a clear run through operations so far. The weather is green and our launch operators are tracking no issues with the launch vehicle, Astroscale's satellite or the launch pad. We're expecting the all clear for launch to come at the go, no-go poll, scheduled to start at the T-minus 12-minute mark to lift off. Before then, though, let's get to know a little bit more about today's exciting mission with Astroscale. On board Electron is Astroscale's ADRAS-J spacecraft, which stands for Active Debris Removal by Astroscale Japan. ADRAS-J is designed to inspect a derelict upper stage of a Japanese H-2A rocket left in low Earth orbit since 2009. ADRAS-J will approach and inspect the rocket stage in orbit with a view to better understanding what it would take to potentially dock with the stage in future and then remove it from orbit to eliminate space junk.
Once deployed from Electron today, the spacecraft will spend the next few months flying around the old rocket stage to better understand its condition and record how it moves in space, at what spin rate, on what spin axis, and more. Now, what makes rendezvous and proximity operations like this tricky is that objects like old rockets and dead satellites don't provide any GPS data. The debris has to be approached slowly and carefully to avoid collision before ADRAS-J can switch over to its own sensors for a safe advance. Meeting up with a piece of debris on orbit while travelling at speeds of around 27,000 kilometres an hour is as complex as it sounds, and a task that requires absolute precision to make sure the satellite is deployed close, but not too close, to the H-2A rocket.
Satellite deployment bullseye, though, is where Electron's kick stage excels. The kick stage has its own small but highly capable 3D printed engine called Curie that can start and stop on command to manoeuvre ADRAS-J into position on orbit with pinpoint accuracy. The kick stage has preparing for another bullseye today. Here's more from Astroscale to tell us about ADRAS-J and their overall mission to clean up orbital debris for the benefit of us all. Today's launch is our 44th Electron launch overall, our second for the year, but it's the first time we've flown for Astroscale, and we could not be more excited to work with this innovative team.
We are now coming up on 12 minutes left in the countdown to launch, which means that soon our operators will conduct the go, no-go poll for this launch. Now, this poll will run through each of the mission's monitored stations to check on their status and whether they are ready to proceed with the final steps before liftoff. You'll soon hear our launch director for this mission, Michael Pearson, undertake that poll. So let's listen into Mission Control now and hear how it goes.
And all stations LD on mission proceeding with the go, no-go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
VCON.
VCON is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
RF.
RF is go.
MM,
MM is go.
and LD Sup.
LD Sup is go.
Okay, all stations, the go, no, go sequence is complete. We are T-minus 11 minutes and 11 seconds and counting. We are go for terminal count at T-minus 10 minutes, and from this time on, the 3-word hold procedure is in effect.
That was Mission Control confirming that Electron is ready for launch, and so is the range at Launch Complex 1. Astroscale's payload is healthy and now a step closer to being deployed to space. We are still targeting a liftoff time of 0352 local time or 1452 UTC and heading to a 600-kilometre orbit for today's mission.
You might have noticed from the camera view today that in those middle desks you'll see our Space Systems team popping in and out as we're actually running 2 mission campaigns from the same control room. A big group of the team in there are operators from our satellite side of the business who are preparing to bring home our Winnebago spacecraft, the satellite we've built and operated for a company called Varda Space Industries. Over the past 8 months, our spacecraft has enabled its attached Varda manufacturing capsule to produce ritonavir crystals, a drug commonly used in antiviral medication for HIV and hepatitis C. With the manufacturing process complete and federal and range approvals for the capsule's re-entry, it's time now to bring the mission home.
Over the next several days of 24/7 operations, they will be commanding our satellite to perform a series of engine burns that will set Varda's capsule on a trajectory to land in the Utah desert no earlier than February 21st UTC. It is a super exciting mission our team can't wait to bring home, and it's great to see our Mission Control Center being used for both a rocket launch and a spacecraft re-entry campaign at the same time. While we wait through these final few minutes before liftoff, let's take a look at our Electron rocket for today's mission. Electron is the world's first carbon composite orbital launch vehicle, and we chose this material not because it looks cool to have an all-black rocket, but because it is incredibly lightweight while retaining its strength, and that enables us to dedicate more mass to payloads, which is crucial in a small launch vehicle with small mass margins.
We're often asked why we named this rocket Electron, and the hint lies in the unique engines that power it. Each Electron rocket features 10 Rutherford engines, 9 on the first stage, and a single vacuum-optimised engine on the second stage. Inside these engines is another world first, electric fuel pumps that replace the traditional turbine system typically used in rocket engines. It was this electrical feature that helped inspire the name Electron. Now, designing a rocket is one thing, but building and launching scores of them is quite another. Few people understand this challenge better than our Director of Electron Production, Lee King. Earlier, he joined our Senior Director of Communications, Morgan Bailey, to talk more about the Electron team and what goes into building the most frequently launched small rocket in the world.
So building one small launch vehicle is quite the feat, but what's even more difficult is building 40 plus more. And someone who knows more about that than most people is Lee King, our Director of Electron Production here. Welcome, Lee.
Thanks for having me.
Look, it's launch day, it's super exciting for the team, and probably no more exciting and no more nerve-wracking for the team who have actually built Electron. Tell us what launch day is like for them.
Yeah, launch day for them is super exciting. They are personally invested. They spent many hours, weekends, public holidays building the vehicle. So for them, it's a labor of love, and there's no more greater feat than launch day. So there's an inherent buzz that goes through the factory on launch day. Everyone's super excited. They turn up in mission control and get to watch Electron take off the pad. Every single one of them are wanting to know, what was it I built in that vehicle? What did I touch? What part of my work has provided success to the mission? So it's a great day throughout the factory.
And you certainly never forget your first launch.
Never forget your first launch.
So tell us what goes into building an Electron. We have raw material comes in one door, a finished rocket goes out the other. You're in charge of what happens in between, and what exactly is that?
Yeah, so for production, there's at any one time multiple vehicles getting built at once. To ultimately achieve the amount of vehicles and the rate that we need to be building vehicles continuously. And for the feeder teams that provide all the components to vehicle integration, which is the final team that builds everything together, they are building probably 3 to 4 vehicles at one time in various stages of build. So those components will go through the different feeder teams and the likes of propulsion, mechanical production, composite production, and avionics production. They'll build it and complete end-to-end testing through all cycles of the build. They'll then provide that to vehicle integration, who will do the same. They will put all those components, it's the culmination of the production facility, ultimately. They put all those components onto the vehicle, complete end-to-end testing once again, making sure it is fit for flight, and then deliver that down to launch range.
Easy as that.
Easy as that.
So we've got a big year ahead. We've got some 20 plus Electron missions on the schedule. Obviously that's going to require some scaling up of the team. So I understand you've got a few roles open at the moment.
Yeah, we've got a lot of roles open right across all our different facilities throughout New Zealand and the US. And ultimately the skills that we're looking for, we started in aviation, but really we've grown as a production facility. So while aviation is closely aligned with how we build the rocket, we really leverage all different types and all different skill sets. We have our own training process that we carry out through the production facility. However, we've even gone down the electrical route through electricians in building industry, electricians that are doing soldering of componentry, and then the likes of composite boat builders, the likes of trainees coming through from car apprentices, car building backgrounds, and again, aviation.
So you don't necessarily have to come from a space background to be able to build Electron?
No. Honestly, the biggest thing for us is, yes, you are bringing your life's experience and skill set to the facility, but nobody that starts here in a production sense has built an Electron. Nobody is a rocket builder. No one starts as a rocket scientist here. You will learn how to build Electron. We will give you the skill set that's required to be able to. What we are looking for is that attention to detail through your day-to-day life, through what you do in your job. We're not just looking for good enough, we're looking for that next level above good enough. And attention to detail starts there, but it's really your attitude, your willingness to learn, your hunger for the space industry, and your desire to really exceed your limits of what you thought was possible.
Sounds exciting.
Yes, it is.
Well, you've got a big day ahead of you, so I'll let you and the team get back to watching launch, but thank you so much.
No problem. Thanks for having me.
Right now in the countdown, we are getting close to a fully fueled Electron as we prepare for flight. We time our loading of kerosene and liquid oxygen to as close to launch as possible to make sure that the super cold LOX propellant doesn't warm up before we need to use it. Though Electron is a small rocket, it still requires more than 12 tons of propellant in the first stage to get to space. We should hear the call that at T-minus 1 minute that LOX loading is complete on Electron.
Shortly after that, the team will wrap things up with the first and second stage when they confirm that both are pressurised for launch. At T-minus 10 seconds, our launch director will count down with the clock to lift off with Electron's Rutherford engines then set to ignite at T-minus 2 seconds. Let's hand over now to Mission Control. The first call we should hear from our operators at T-minus 2 minutes is the switchover to the rocket's onboard flight computer for the countdown. We'll be back with you shortly after liftoff. Show the way, Address J.
Avionics batteries have switched to internal power. The vehicle is fully on internal power. FTS is green and enabled for flight. Maximum recirculate. Anti-gathering is disabled.
Stage 1 and Stage 2 tanks are pressed.
I have low end approach enabled.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
T plus 30 seconds and Electron has left the pad at Rocket Lab Launch Complex 1 in New Zealand, carrying the Astroscale Address J payload. In a few moments, Electron will curb its engine power just a little to pass safely through the launch milestone known as Max-Q, or Maximum Aerodynamic Pressure. This is the moment during ascent when Electron will experience the most amount of stress on its way to space.
Cleared Max-Q.
And Electron is clear through Max-Q. All is looking nominal at T plus 1 minute and 24 seconds into the mission, with Electron cruising along at speeds of over 2,600 kilometres an hour and now at 23 kilometres in altitude. If you've joined us in the past, you'll be very familiar with the next 3 events happening back to back.
First will be the shutdown of the first stage's 9 Rutherford engines in preparation for when the first and second stages separate from each other, and then the engine will start up on Electron's second stage. Those actions are called out as MECO, which stands for Main Engine Cutoff, followed by stage separation and then stage 2 ignition. We are expecting to hear those calls from Mission Control in just a few seconds.
AOS Chathams. Entered burnout detect mode.
MECO confirmed.
Stage separation successful.
Stage 2 ignition confirmed.
And that's MECO confirmed, stage separation and second stage ignition, all seen from onboard cameras on Electron. From the second stage, we're now getting a live view of the space-optimised Rutherford engine that's powering the mission to orbit. Up next is fairing separation in just a few seconds. We'll likely see those 2 fairing halves fall away after the split, so watch out for that on your screen.
Fairing jettison succeeded.
That was the 2 fairing halves successfully deployed there, introducing Astroscale's payload to space. The mission is moving along in this second phase of the journey at more than 8,600 kilometres an hour now, at an altitude of 127 kilometres.
The burn on this Rutherford engine should continue for another 4.5 minutes or so before we get to the final stage separation between the second stage and the kick stage with Astroscale's payload. For that event, we should see the Rutherford engine on the second stage turn cold before the stages separate. But before we get to that nozzle on your screen there will stay bright and hot as Electron continues on its trajectory to orbital insertion.
Electron has hit the 9,800 kilometre an hour mark on its way to orbit with Astroscale. We're 4 minutes and 14 seconds into the mission now, having already completed liftoff, clearance through max Q, main engine cutoff, stage separation and second stage ignition. We have around 5 minutes left in this second stage engine burn to take the mission all the way to its target perigee of 522 kilometres. The perigee is the lowest point in an elliptical orbit, and from there the kick stage will coast around to the apogee of 600 kilometres. The kick stage will then ignite for final payload deployment of ADRAS-J.
You can see from the telemetry data on your screen that Electron is now moving very quickly towards orbit. The second stage is on a nominal trajectory with the Astroscale payload, with everything looking great so far on this mission. At T+9 minutes is when that second stage engine is expected to end its burn and shut down for the final stage separation. And before we get to that, we'll first need to perform an action unique to the Electron rocket called a battery hot swap.
This happens only on the second stage of the vehicle, about halfway through the Rutherford engine burn time, when the first set of batteries that have been powering the engine's electric pumps are close to being empty. The battery hot swap replaces that first set with a new battery pack to power the engine the rest of the way. We're coming up on that milestone now, which should be coming across the net shortly.
Holding nominal, approaching hot swap in roughly 30 seconds.
Throttling down.
Hot swap successful.
Guidance is nominal 100.
We saw a flash of it there as it dropped away. The battery hot swap is now complete. Another major milestone with a green tick. Soon it will be shut down for SECO, or second engine cutoff. This is the same process the rocket went through for main engine cutoff on the first stage, before the stage separation earlier in the mission. The second stage engine will throttle down before shutting off completely, ahead of the kick stage separating with the Astroscale payload, so the mission can continue on to payload deployment. SECO is scheduled for T+9 minutes 5 seconds, which we are coming up to shortly.
Still holding nominal.
You'll notice on the right side of your screen the fuel and oxidizer levels of the second stage engine. With just 22% of kerosene and 22% of liquid oxygen remaining, that puts us with just over a minute until the end of the second stage engine burn. With Electron moving at 20,000 kilometres an hour now, we're coming up quickly on orbital velocity. All right, 2 more milestones this side of the coast phase of launch. SECO, or second engine cutoff first, followed by kick stage separation. The vacuum-optimised Rutherford engine will throttle down ahead of shutoff, and then the kick stage will separate from stage 2. Let's check back in now with Mission Control and listen to those calls.
Entered burnout detect mode.
Terminal guidance, 18 seconds remaining.
Seco confirmed.
Stage 3 separation confirmed. And nominal transfer orbit achieved.
Great news there from Mission Control, and as you saw on your screen as that engine nozzle cooled down, we have had a successful second stage shutdown and separation of the kick stage. Astroscale's payload will now enter a coast phase as it completes its first lap of the Earth, with the kick stage on an elliptical trajectory. Once the dots connect is when the kick stage's Curie engine will ignite, placing the payload in its final orbit.
Once ADRAS-J has been deployed, the satellite will use ground observation data to determine exactly where its target H-2A spent rocket is, so the satellite can cautiously approach and use its own onboard rendezvous sensors to get closer. The spacecraft's job on this mission is to understand what condition the H-2A rocket is in. Is it tumbling, and if so, how quickly? What is its exact location, and can it be safely latched onto? This is called the Rendezvous and Proximity Operations, or RPO, and a successful demonstration of RPO on this mission could open up a world of on-orbit servicing possibilities, including active removal of space debris.
For now, the kick stage continues on its first orbit of Earth with Astroscale. We'll be back here on the webcast in about 50 minutes or so to take you through the final moments and payload deployment, set to take place at T plus 1 hour, 4 minutes and 30 seconds. See you here soon.
Curie ignition confirmed.
Great news from Mission Control. The kick stage's Curie engine has ignited for a second time for a brief 30-second burn.
Curie cutoff confirmed.
And good shutdown of the Curie engine, which means up next is payload deployment for ADRAS-J.
Many more to go, including our 50th Electron mission coming up soon.
We will end the broadcast now, but for those that missed it, we'll soon have a replay of today's launch. Remember to follow Rocket Lab's social media pages for more information and to learn when our next launches are coming up. This is Rocket Lab Mission Control signing off.